Hi everyone, I'm Kristin, a Cloud Technical Resident at Google Cloud, and I will be covering how to orchestrate batch Spark notebook executions on Dataproc Serverless. This will include typical customer use case and solution, along with the step-by-step demo on Google Cloud Platform to run your Spark workloads without having to provision, manage, or scale the cluster. It supports batches and sessions. We'll be focusing on running notebooks as batch jobs on Dataproc Serverless in this video. Running enterprise-grade data science and machine learning workloads, these are some known challenges that Dataproc on Google Cloud Platform can help addressing. Scalability and performance. The scale of data and models are large and tend to grow over time, and as we're aware of it, more complex an application gets, the more difficult it is to address capacity limits, bandwidth issues, traffic spike, and many more. Manageability. For typical enterprise ML deployment, planning and configuring appropriate cluster size, machine type, performance tuning, and maintenance costs are complex. So there is a need for more flexible and manageable solution that lets you just focus on the core business logic of ML that matters the most to your business. Typically, customer will want to lift and shift notebooks from their legacy environment to Google Cloud Platform. In this scenario, customers want to operationalize and orchestrate the existing notebooks with minimum effort. The migration is a two-step process. First, we will migrate and stage Spark notebooks that were in legacy data lake to Google Cloud Storage. Then we will orchestrate notebook executions on Dataproc Serverless as a batch job. As this video is about orchestrating notebooks on Dataproc Serverless, I haven't covered notebook development in the video, but we recommend you use Vertex AI Workbench for interactive notebook development on Jupyter UI provided. Now let's look how you can create a batch job to deploy notebooks on Dataproc Serverless. So here we have Vehicle Analytics Executor Python file shared in the description sections, so clone that and submit it as PySpark job to Dataproc Serverless. This executor Python file executes the Spark notebooks and write the output to the Google Cloud Storage. From Dataproc on Google Cloud Platform, we're going to navigate to Serverless Batches, then create a job for our notebook execution. We leverage this Vehicle Analytic Executor Python script we have shared in the description sections, which calls a paper mill utility that will take in the arguments and do the execution for it. So we can pass input and output notebook path as argument and submit as PySpark job. If your notebook requires adding Python packages, you can pass the requirement.txt file path here, and you could also add additional Python files, jars, or any other reference files that are in the cloud storage when submitting this job to Dataproc Serverless. Once this job is submitted and completed, it will store the execution result in the target cloud storage path. It will take a few seconds to execute our sample analytics notebook. Once that's done, you could view the result from Output Console or navigate to the Output Notebook path that you assign at a job creation and download the file to your machine. This is a sample output notebook of vehicle analytics you will see in your bucket that executes few fundamental data analytics on a Spark session. You can check out the GitHub link for code and more details. You can orchestrate this job using Dataproc Workflow Template or Cloud Composer. Now let's take a look how we can orchestrate this using Cloud Composer. We will use this specific Dataproc create batch operator from Airflow library to create a batch job on Dataproc Serverless. For batch configurations, you will need to include three things that we just covered. So job type, Python file, and arguments. Sample DAG file can also be found in the GitHub repository added to the description. Before executing DAG, we have a few things to confirm. First, you need to create a composer environment if you don't have it already. Second, you need to place all the source files in your staging bucket. Again, all the files including Vehicle Analytics Executor Python file, sample dataset, dependencies, reference files, and Jupyter Notebook can be found in the repository in the video description. Please make any additional changes as you like. For the third step, from your composer environment, you will click here to open Airflow UI and go to Variables to set up variables that you're calling from Airflow code. If you added additional variables to your DAG file, please make sure you declare those variables here.
Finally, you're going to navigate to the Environment Configuration tab and go to the DAG folder to separately store your DAG so that Composer can sense and run it when it's triggered. Once you place your DAG files in the folder, you can view your DAG name and you can trigger it. So I click on my Vehicle Analytics DAG, and I've just triggered it by pressing the play button on the top left. You can navigate to this Graph tab and monitor the executions. The tests will be executed in their order as specified, and it will show you different colors indicating different results. And from this grid tab, you can see by the task how much time each task is taking, or total has been taken, and real-time log as well. Once all the tasks have been successfully executed, you can view the output result and log from here as well.
So in this video, we saw how Dataproc Serverless can be used to orchestrate and run Batch Spark notebook application at scale without having to provision and manage complex clusters. Running end-to-end data science workloads on Dataproc Serverless can help reduce the data value gap. Please check out the GitHub repository link and blog in the description for getting hands-on and for more details.